Hello everyone, myself Sai Prasad, Alexei in the Ahmedabad High School and the Junior College. Welcome to a series of the lectures of 10th class maths. We have started a discussion of similar triangles. In the last session we discussed about Pythagoras theorem, right. On that basis we have solved few examples and few exercise problems in the last section. Let us continue the Pythagorean theorem with few more problems. Okay, see here. The question given here it is ABC is a right angle triangle which is right angled at B. Let D and E be any points at AB and AC. Okay, then he is asking us to prove AE square plus CD square, where is it here, is equal to AC square plus DE square. Is it okay? Shall we do? Now let us do. If you first of all you have to observe how many right angle triangles are there. One is ABE, one is ABC, right, and one more is DBC and one more is DBE. Is it right? These many right angle triangles are there. Yes or no? First of all, let us consider the left hand side AE and CD. Where is AE? This is AE and this is CD. Okay. Now let us write triangle ABE and triangle BDC. Okay. In triangle ABE, I know that AE square is equal to AB square plus BE square, AB square plus BE square, right. Again if you consider the triangle BDC, from triangle BDC I will write it as CD square is equal to BC square plus BD square. Is it okay? Now let us add these both 1 and 2. If I add 1 and 2, I will get it as AE square plus CD square on left hand side. If you consider right hand side, AB square plus BE square plus BC square plus BD square. Okay. Now if you observe, let us consider AB and BC. If you see here AB and BC, what is it? That is nothing but AC, right? Yes or no? Let us write those both together. AB square plus BC square plus BE square plus BD square. Is it okay? Now see here, what is AB square plus BC square? That is nothing but AC square. That is AC square. Again, what is BE square plus BD square? BE square plus BD square is nothing but DE square. That is what he asked us to prove, right? Yes or no? Just an inference, just to write, since triangle ABC and triangle DBE are right angled triangles. Is it clear? Did you understand? This is again a simple question. You need not think with a heavy mind for this kind of question. Okay. Let us move on to the next question. He is asking us to prove that 3 times square of any side of an equilateral triangle is equal to 4 times the square of its altitude. Okay. How to do it? Now say here, let us solve it. If this is an equilateral triangle ABC with a height AD. Okay. See here, remember, whatever the height it is there in the equilateral triangle, it will bisect the base into 2 equal halves. Is it okay? Which means here BD is equal to CD, right. Now see here, what is he is asking us to prove is 3 times square of any side. Let us assume B, this AB, 3 times square of any side, let us assume AB, is equal to 4 times square of its altitude. What is its altitude? AD square. That is what we have to prove it. Okay. Now let us prove. How to do is, here there are 2 right angle triangles, one is ABD and one more is ADC. Okay. Let us consider triangle ADB and triangle ADC, right? If ADC, I mean ADB is a right angle triangle, what is the hypotenuse here? AB square is equal to AD square plus BD square. Is it okay? Similarly, right hand side, what is ADC? Or else we can even simplify with the first thing also. Okay, see here, what is AB square? AB square is one side. Let it keep it like that only, right? What is BD square? Right? BD is half of BC, right? Yes or no? BD is half of BC square. Okay. Then what is BC? Tell me. Let us write a reason here. Since D is midpoint of BC. Okay. Then next, let us simplify this first. AD square plus 1 by 4 BC square. What is BC? It is an equilateral triangle, right? All sides are equal. Can I write this BC as AB? Let us write. That is equal to AD square plus 1 by 4 AB square. Is it okay? Since triangle ABC is an equilateral triangle, whereas AB equal to BC equal to AC. Isn't it? Reasons are very important. Now, let us send this for this side. What it will become? This will become minus 1 by 4 AB square is equal to AD square. If I take 4 as common here, that will become 4 AB square minus AB square is equal to AD square. 4 AB square minus 1 AB square. 4 में से 1 निकाले तो I will get it as 3 AB square is equal to 4 AD square. This is what he asked us to prove, right? Yes or no? Is it clear? Once again, let me repeat. He is asking us to prove that 3 times the altitude, I mean square of any side is equal to 4 times the square of its altitude, that is 3 times AB square is equal to 4 times AD square. Is it okay? For that, I have written 2 right angle triangles, one is ADB and one more is ADC. Okay, I have considered only one right angle triangle, that is ADB. From that, AB is a hypotenuse, so that AB square is equal to AD square plus BD square, right. After that, here BD is half of BC. Okay, that is why I have written it as 1 by 2 BC whole square, so that 1 by 4 BC square. What is BC? Since all sides are equal, I will write it as AB, right. I have brought it this side, then I have taken LCM, then I got 3AB square is equal to 4AD square. Okay, let us move on to the next problem. Fine. See here, the next question given here, it is PQR is a triangle right angled at a particular point P, and M is a point on QR such that PM is perpendicular to QR, show that PM square is equal to QM into MR. Okay. See here, he is telling that a PQR is a right angle triangle which is right angled at P. Okay. If I draw a triangle like this, it is right angled at P, and he is telling that M is a point on QR. M is a point on QR such that PM is always perpendicular to QR. Is it okay? Then he is asking us to show that PM square equal to QM into MR. Okay. Now let us write the different triangles. What are the different triangles we have? Triangle PQR is a right angle triangle. Triangle PMR is a right angle triangle, and triangle PMQ is also a right angle triangle. Okay. Now if you observe here, let us consider triangle PQR and triangle PMR. Okay. If you observe here, R is common for both of the triangle, isn't it? Let us write them. If I observe, I am drawing very smallly so that you can easily understand it. I am trying to draw each and everything. Okay. R is common thing, R, and here angle is P for the first thing and one more is Q, and here angle is at M, obviously one more is P. Is it okay? If you observe here, QP, PR, QR, MR, PR, PM. Okay. If you observe here, PQR is a right angle triangle, right angled at PQR, and here PMR. Okay. So that here it is right angled at M. Is it okay? Did you understand? Right? If we see here, angle R is equal to angle R, which is common in both the triangles, which means angle QRP is equal to angle PRM, which is common. Angle QPR is equal to angle PMR, which is 90 degrees. Therefore, triangle PQR is similar to triangle PMR. Isn't it? From this, can I write it as PQ by PM? From this, PQ by PM is equal to PR by MR. Okay, let us consider it to be first equation. Let us put it like that. Now, let us consider this triangle and the whole triangle, that is, this is the first one, and let us take second triangle, that is triangle PQR and triangle PMQ. Okay. What are the things here if you observe? One is triangle PQR, which is right angled at P, and one more is here angle Q is common for both of them, M, and one more is P, isn't it? Q is common here, M is right angled and P is also right angled. Okay. If you observe here, again the same thing, let us write here angle RPQ is equal to angle PMQ, that is 90, and angle RQP is equal to angle PQM, that is common. Okay. Therefore, triangle PQR is similar to triangle PMQ. Okay. Now, we have to get this PQ by PM on both the sides. PQ by PM, where is it? Let us consider here PQ by PM is equal to PR by MR, we got here. Then we have to take it from this side. Is it clear? See here, here it is PQ, here it is PM, here it is QR, here it is PR. Okay. Right. If you observe here, can I write this as PQ by MQ is equal to PR by MP? Isn't it? Is it right? Did you understand? Now, this is nothing but second equation, right. Now, we have to check to get PM square is equal to QM into MR. How do we get, where do we have PM square? Here we have PM square. Okay. From 1, let us substitute this PM into here, or else let us write QM and MR is there. QM is here, where is QM? QM is here and MR is here. If you observe here, can I write this as PQ by PR and PQ by PR separately, right? Let us write it here. This will become as PQ by PR as PM by MR. This is first equation. Here also let us write it as PQ by PR is equal to QM by PM. This is second equation. Okay. If we observe here, these both things are same, right? Yes or no? Right. From this both, from 1 and 2, I can write it as right hand side, that is PM by MR is equal to QM by PM. Just cross multiply PM into PM is PM square, QM into MR, that is what he asked us to prove, right? Yes or no? The only thing you have to remember is which two triangles are to be considered. Okay. Now, let us move on to the next problem. This is again a very important question, right. What are the given condition? He gave that it is an equilateral triangle AB equal to BC equal to AC. Okay. And he is telling that D is a point on the side BC such that BD is equal to 1/3 of BC, right. And let us consider a point E which is perpendicular. Okay. Obviously, if E is perpendicular, then E will be midpoint of BC, which we have seen in the last thing. This is given. Then let us construct, draw AE perpendicular to BC, so that BE is equal to EC, or else we can write it as BE is half of BC. Is it clear? BD is 1/3 of BC and what is it? BE is half of BC. Those are the two given conditions for ours. Now, let us consider, there are different triangles. How many triangles do we have now? That is ABE and ADE, isn't it? Yes or no? Right? Now, let us consider those two triangles. What are we going to get? Let us see. Right? Consider triangle ABE. If it is triangle from triangle ABE, what is the hypotenuse here? AB square is equal to BE square plus AE square. Okay. Similarly, one more triangle. What is it? From triangle ADE, this triangle, AD square is equal to AE square plus DE square. Let us assume this to be 1, this is 2. Let us subtract these both, 1 minus 2. What we will get? AB square minus AD square is equal to, here it is BE square plus AE square minus AE square minus DE square. If you observe here, AE get cancelled, yes or no? And the left out is BE square minus DE square. Okay. There are different things you can solve it. You can solve in different manners. The whole thing, it should be converted either in terms of AD or in terms of BE. However, we can't convert into AD. It is better to convert everything in terms of BC. So that BC is nothing but AB, right. If you observe here, what is BE? BE is half of BC, right? Yes or no? BE is half of BC, right. What about DE? DE is, what is it? BE minus BD, that is BE minus BD. Yes or no? What is BE here? BE is half of BC and what is BD? 1/3 of BC. Let us write it, 1/2 BC whole square minus, what is BE? Tell me. That is half BC minus, what is BD? BD is 1/3 of BC whole square. Okay. Now, let us simplify this. This will become 1/4 BC square minus, LCM is 6, 3 BC minus 2 BC is 1 BC whole square, which is 1/4 BC square minus BC square by 36. Is it okay? Let us take everything to left hand side. Here again, AB square minus AD square. Okay. See here, AB square minus AD square is equal to, here LCM is, okay, let us keep it like that only, 1/4 AB square minus 1/36 AB square, right. BC and AB both are same, right. Now, let us take this AD, that is remaining, let us bring everything to left hand side, that is AD square is equal to AB square minus 1/4 AB square plus 1/36 AB square. Okay. What is the LCM here? 4 and 36, isn't it? The LCM of 4 and 36 is always, LCM will be 36. Therefore, we get it as 36 AB square minus 9 AB square plus AB square. 36 minus 9, how much will be? 27. 27 plus 1 will be 28 AB square. Is it okay? Fine. Now, let us cross multiply and let us cancel it. In which table do they cancel? 4 7s are 4 9s are. Therefore, we get it as 9 AD square is equal to 7 AB square. This is what he asked us to prove. This is AD. Is it clear? Fine. Once again, if you observe here, he gave an equilateral triangle ABC such that D is a point, so that BD is equal to 1/3 of BC, and he is asking us to prove 9 AD square equal to 7 AB square. I have taken a particular point E which is perpendicular to BC so that this will be a midpoint of this, okay, which means BE is half of BC and BD is 1/3 of BC. From that I have taken the triangle ABE and triangle ADE. I have taken two hypotenuse Pythagorean theorem, I have subtracted it, I have substituted the whole thing, I have converted everything in terms of BC, right. In the finally I have got it as 9AD square is equal to 7AB square. Is it clear? Did you understand? These are the different basic things which you have to remember. Is it clear? There are few more problems of Pythagorean theorem in the last exercise, so that you can practice more and more question. Okay, fine. These are different questions of similar triangles which you have to learn. Let us continue our discussion of similar triangles with the construction in our next session. Okay, this is for today. Let us meet in the next session with the more concepts of similar triangles. Okay, thank you.